related project from Werner Koch here. And so yesterday was already a warning, or this morning, maybe this morning, surf bug. Yes, so stop using servers. Just this morning, let's see date. Anyway, so just warning, stop using this immediately. The good news is only Fedora 34 in development and Gentoo use this so far. Here is January 29, there, just some 2-3 hours just later. Announced availability of Libgcrypt 191, another fine little data set in our sample size here of programming in C. What could possibly go wrong? Buffer over underruns, use after free, and security. We got this, maybe not. Recurring find here. And so what is the issue? They got their node from Tavis Ormandy, recurring security fame here. Surf bug while testing heap buffer overflow. Also, yeah, they developed this for a year or two, and then Tavis Ormandy comes along with like, yeah, YOLO, whatever. By the way, grave bug in your block buffer management. So with people continuing to write stuff in C, we probably have here years and decades or centuries to come of security vulnerabilities. And if we take a look, so I actually diffed this in T2, we didn't update to this yet. Thankfully it didn't came along that. So the issue is, here's a changelog solution here, upgrade immediately, because obviously, and so noteworthy changes in Libgcrypt stuff, it's actually a lot. So normally if you would have just one security thing, you could actually diff this here nicely. I was scrolling over that, didn't also here, it's yeah, on the first glance, didn't find that immediately, so peeled this out here with Git lab or Git web here of their own hosting fame. This is a change. Did not expect HD. Also, yeah, so a recurring theme here. Do I make this stuff up here live on this channel? Manual buffer management stuff in C, because apparently that is the most performant and most amazing. We got this. And yeah, so didn't expect HD, whatever HD stands for, hash something, whatever, grip, deep block, something, yeah, being greater than digest block size. However, digest final function may set HD count to larger value. No, it writes, if write is called after final function and HD count gets to large value, copy length parameter may have larger than size HD buff and may cause a heap overflow. Oops. So yeah, new sudo vulnerability. What do you mean new since yesterday? Because we made the broadcast over the sudo. So yeah, recurring theme, writing stuff in C will continue to break for centuries to come. Resolution, use higher level abstractions, stop thinking to be more clever than your compiler. Rust, Go, Swift, potentially C++ without using good old-fashioned C stuff. So the fix is as easy as cipher hash common block write of if count larger than block size, and this happens only when write is called after final. Writing after final is being used. Writing after final is used for mitigating timing attacks like HD count 0. Like, So yeah, there you have it. Just one tiny little. Also, yeah, also C++ vector stuff. Even if you say, okay, Rust and Cargo are not Rust and Go are not for me, or Swift or other languages in between. At least C++ with kinda sorta nearly zero cost overhead vectors of fine generic programming, and like iterate nicely over compiler and generic container check stuff, and do not reinvent the buffer wheel. Also, yeah, slightly this makes me also throw up a little bit of static const char buffer 128 there. And okay, this is a test. Okay, fine. I take this somewhat back, but also, yeah, why does it need to be static in? Doesn't look the most. Yeah. Anyway, it's only test, but nonetheless, like something. Anyway, so yeah, that is all it needs in 2021 to have a heap overflow in one major crypto component. We can also try to update this. Actually, not yet updated that. Let's see if it compiles. Let's also, why do we have some random garbage apparently? Let's also, I think I libgcrypt updated this right now. Let's see if this still compiles libgcrypt, or if it needs other dependencies. Sometimes they do. Did we build here x86? Build x86 already enough list. I also need to somehow quirk this bloody directory stuff, obviously, because it doesn't scale like that. So it's apparently built. That is sometimes the issue. I have one of those libraries. I think it's libgpg-error. We have some really strange, or they have actually some super strange running, generating whatever metadata of register, alignment, offsets, whatever. Need some cross-patching stuff that is somewhat hilarious. Anyway, yeah, so this just builds. So then I probably, if I think Tevis or Mandy is of probably Google's Project Zero fame, if he still is there, probably if they reviewed this, probably can commit this. Probably their review is most likely better than mine, Libgcrypt, because obviously I don't even have time for this kind of security review. There we have it. I don't really need to flex the CVE. Usually I flex the stuff CVE, whatever. I don't really need with this because we didn't have the previous version, so it's not a CVE in T2. That is our, some say amazing, certainly. Me too, just raw open source Linux stuff. So because we never had the previous version due to sheer luck, we don't really need to flex the CVE. Anyway, there we have that. In case, and yeah, you probably want to share, like, and subscribe, and certainly subscribe for all the future data points of making fun out of others, people, buffer over under runs, use after free. We they got this not, and why I don't trust C code at all anymore, and we urgently, in my opinion, long story short, too long didn't watch resolution, stop freaking trying to write C code. Even the best of the industry, Werner Koch, of course, doing gnupg probably for 20 years, if not longer. We can actually gnupg Wikipedia that. And yeah, if you don't want to end up here in the security debriefing, then it's probably the best idea. Yeah, 21 years, what a good guesstimate I usually have here is exactly a more kinda sorta. Actually, this I'm longer in open source than this project is old. That's it for this video. I hope you learned something. I hope to see you soon for a more secure future. And Marco writes, actually this is where 60 fair reduce the risk of this stuff having just being readable and clean by handling buffer just in one place instead of handling cleanups. Yeah, also C people always spot C++ vectors like 100,000 times slower. No, of course not, unless of course you do stupid things like using the add function that does bound checking on each call. Of course you don't do this. Also, of course, this proper high-level stuff, it doesn't need to be 100,000 times slower, which of course C++ vectors are not, because they are kind of zero cost abstraction anyway. And how should this be solved in a high-level language? Of having the compiler determine the bounds of the loop and the size of the container beforehand, and only do this checking before some loop, and not obviously, but yeah, GCC even for C++ highly optimizing compiler already for a decade or two. So the people who always cry like, but the performance, like, yeah, you don't, even in a high language, you don't bound check on each iteration. Obviously you bound check before that, and again, preferable generically and automatically by the compiler, because we are all humans, and if you leave this to humans like that in C, then obviously you end up with recurring security issues. More comments. Have to write something which needs to be executed a lot, so you want to be fast. Which programming language would you use instead of C? Well, of course, Rust is just as high performance. I have my personal problems with Rust, bootstrapping, cargo, micro dependencies, and if not last but not least, the readability of the language. But of course there's Rust there is Go, there is Swift, and personally, even I say this, in my opinion, the open source state of security and even advancements in features and stuff would probably be a magnitude better if just for C++ and the avoidance of use of good old-fashioned C stuff and just using at least STL containers all over the place shouldn't be too hard, should be approximately kind of the same performance, more or less. Yeah, otherwise, leave in the comments below, and Marco likes Okamel just saying, yeah, also a friend of mine using Haskell already for 15 years ago or so. And so yeah, there is a lot of stuff. Basically, there is no excuse to use C. And I said this also before, due to the nature of static compilation, you compile this once. Not even the greatest performance, in my opinion. Some dynamically code generation stuff could be vastly more performant, because for distribution, as seen here on this channel and other major components like Windows and macOS, you compile for the least common subset of instruction set architecture, and you're not necessarily using the latest and greatest AVX stuff unless you have custom assembler or built this multiple times. And in my opinion, I said this before, some lightweight jitting stuff could even potentially lead to much higher performance of at runtime or install time, like Google's Android runtime stuff, ahead of time compilation, whatever the case might be, because right now, with most Linux distributions, you don't even get with C the highest performance. You easily leave something on the table because you're not running unless you're using T2 and build everything for the latest and greatest AVX that might be in your CPU. Not even the greatest performance, so there is a lot of innovation probably for performance and security. That's it for this video. I hope you learned something, and share, like, and subscribe for this kind of IT content and other fun stuff, and don't forget to avoid using